So just like for proportions, there's a Z star and a T star. Depending on what they give us, depends on whether we use T star or Z star. Okay, we'll talk about that. But we're going to talk about T star right now. I'm going to teach you how to find it. So T star is something that happens with your sample, and it happens with degrees of freedom. Okay, so, whoops. These are your degrees of freedom on this side right here. Inside right here is your T star. So if I told you our sample size was 25, okay, our sample size was 25, our degrees of freedom would be 24. That's the first thing. Okay, so we have our sample size, which was 25. Our degrees of freedom are 24. Alexa, we're in the blue book in the very back on the cover, okay, when you get a chance. Okay, now, it's going to work the same way Z-star did, okay, except that now I give you a sample size, you have to look up the degrees of freedom, and then you have to figure out the confidence interval. Okay, so here we go. I have a sample size is 25, which means my degrees of freedom is 24, and I want to be 95% confident. So at the very bottom, you go to 95% confident, and then you're going to go all the way up to 24, and that number right there, that 2.064, is your critical value. That would be T star. I will tell you guys when we use T star versus Z star in a second, but I want to practice finding T star, okay? Here we go. My sample size is 16, and I want to be 99% confident. My sample size is 16. I want to be 99% confident. So I want you to look up your Z star. So, we had a sample size of 16. What's my degrees of freedom? 15. So my degrees of freedom are 15. I want to be 99% confident. What does that make my T star? Who knows?
2.947.
Okay. Let's do another one.
Now, when you said degrees of freedom, it's just going to be one less than the sample size?
Yep.
Okay.
What is the degrees of freedom? And we want 90% confident. And what did you say, Matt, it was?
1.699.
So the question becomes, well, what happens because the T star is not in the chart, right? Like for 60, if I had a sample size of 67 and you go to look for that, well, it doesn't exist. So if you start looking at the numbers, they're getting really closer and closer to each other. And what's going to happen is you're going to estimate for those higher sample sizes. They don't happen very often, but when they do, you'll estimate. The other thing is that we'll err on the side of caution, and we also will use our calculator to do this test. Now, they don't always give us our T star, so in the calculator, but you can figure it out. Okay.
So if the
So T-star is used in two different ways. It's used for confidence intervals, and it's also used for significance test. Right now, we're using it as confidence intervals, so we're going to use the bottom numbers. Once we get to significance test, we're going to use the top numbers, the upper tail probability. Okay. T-star is kind of like a Z-score. I don't want to say it is exactly that, but it is kind of like that, and that's how it would be used. But right now, we're using confidence intervals. So the top numbers where it says upper tail probability P, we're going to use that starting next chapter. We'll use those for significance test. Okay. Okay, so in the blue book, we're going to do problem 1031 on page 650. And right now what we're going to do is we're going to enter this data into our calculator. And then we're actually are going to talk about how to do this problem. Okay?
Does it matter what order?
Okay, so what we're going to do, you guys, is we're going to okay, so we're going to make a stat plot, and then we're going to do a stat calc 1 and get our information, like our mean, our median, all of that. So okay, so here is the thing. When you go, you're only going to do this with means. So, you want me to do the CLT again? No
Yes.
more. Okay. So, Ethan's not here to see it, and okay. So, with means, you have to do, when you do normality, there's two ways that you have to do it. If you get, if you have data, which they just gave us data, right? In order to prove normality, there's two things that you have to do. For normality, the normality condition, not only do you have to draw a box plot or a histogram, like you have to show it. And you guys, it does not matter if they give you 5 pieces of data. If they give you data, you have to draw some type of plot. Whether they prefer box plots because you can show outliers and such. Not that you can't show outliers with histograms or stem plots, but a box plot is better. That's what they're looking for. So for the normality condition, you have it no matter proportions or means. But for means, if they give you data, you have to draw a box plot. Now, in this one, can we use CLT? No, we cannot use CLT because our sample size is only 20, and we need a sample size of at least 30. Okay, so that's the first thing. We can't use CLT. But when we look at our plot, is it roughly normal? It's not horrible. I mean, that bar right there isn't great, but it's not horrible. So it's approximately normal, right? It's approximately symmetrical with no outliers. That means we can continue, okay? It's not great, but it's approximately symmetrical. There's no outliers. We can continue. So there are very specific rules for when you have a sample size. So obviously our sample size being greater than 30 is perfect. Now, that right there. Well, what if you do have a sample that's 30 and they gave us data? You still have to draw a box plot. If they give you data, you have to draw some type of plot. Now, what if the plot is skewed? You need to say that. You need to say the box plot shows skewedness. There's no outliers, or there are outliers, however, CLT states that if our sample size is large enough, greater than 30, we can say that our distribution is approximately normal. Okay, so you're looking for mild skewness. This is mild skewness. We have no outliers. Those are the two things. Mild skewness, no outliers, we can continue. Okay, now, what did they give you? They gave you X bar, right? So did you do your one variable stat? one variable stat. Oh, you gotta tell what list it is in. There we go. Is that what you guys got?
Yes.
X bar 18.48.